So I'm going to walk through how to complete this homework for the codebook table as well as the two recodes and table 1 so that in the homework that is due in a few weeks, you have a step-by-step walkthrough of how this works. So I have the homework for Word document open on the right side of my screen, and we were using the homework for dig.sav file. So I have that open here in my SPSS data view. So you can see here we have first that ID variable, which is just a number to identify the person that this information goes along with. Then we have the age, gender, all of these other variables. And we can scroll over, we can see heart rate, previous MI, and number of hospitalizations. If we click on variable view, again, you can see the different variables, the labels here, as well as the values. So we have that as well as the scale of measurement. So going into this codebook, we want to identify what the variable type is. So age here is measured in years. And so if we look at our data, we can see that there's a range of values here across the board, maybe from 45, 41, we have some people up in the 80s. So we're going to say that's continuous because it's on a range of values. Then gender, there's only two options here. And remember, if you want to see the words instead of these numbers for your nominally or ordinally measured variables, you can click this 1 to A button and it switches them to the wording. So if that makes more sense to you, that's totally fine. So here we can see that male and female are our two options for gender in this data set. So that will make this nominal. Then BMI, again, is calculated from height and weight. If we look here, again, it's a range of values. So that's going to be continuous. Serum creatinine, again, same thing. It's a continuously measured variable. Then activity limitations. So this one got a lot of people hung up. So there's four categories here: none, present, past, as well as past and present. So the one, since this has categories, we know that it's categorically measured. So it's either going to be nominal or ordinal. And the only way it could be ordinal is if there was some inherent order to these response options. So since there's no order, you could rearrange these in any set of groupings. So it could be 0 equals past and present limitations, 1 equals past, 2 equals no present limitations, and 3 equals present. That still makes as much sense as this. So this would be then measured nominally. Number of symptoms, so again, that's on a scale. And if you want to look at the data to see that, you just pull this over and look, there's a range. Someone has 0, some people have 4, 1, 3. So it's a range of values, so it's continuous. Oops. And then heart rate. So again, we look at our data and there's a range of values, 64, 74, 76, etc. So that's continuous. Previous myocardial infarction status is either they had a previous MI or they did not. So that means there's two categories, which makes it nominal. And then number of hospitalizations, again, is a range of values. So here, if we look in our data set, you can see that it ranges from, oh no, from 0, let's scroll down a little more, 1, 2, 3, 4, 5, 6, up to 39 hospitalizations. So that's continuous. Let me just turn this off. Okay. So that's how you fill in this variable type here. So now we're going to move on to the recoding. So our original BMI variable here is numeric. It's It's continuously measured, it's on a scale, but we want to recode from this scale into 3 categories so that we can identify if each individual falls into an underweight, normal weight, or overweight BMI scale. So how we're going to do that is go to transform, recode into different variables. So we always want to use the recode into different variables because if you recode into the same variable, it overwrites what is currently in your data file. That way, if you make a mistake, you can't go back and check and see what you did wrong. So we'll recode into different variables, and here you have your output window. So we're going to bring over BMI, our input variable, the original variable, and our output variable will be this new variable we make. So we're going to call it BMI underscore R, or recode. So then I will put in the label for this variable. So recoded BMI into categories. And then we're going to click change. When you click change, the question mark that was up here changes to the output variable name you included. Now we're going to go to old and new values, and we're going to put in the old values and our new values. So this tells us that we want anyone whose BMI was 18.49 or lower to be in our underweight group. So we're going to click the range lowest, that's the value we're putting, or that would be like 0 in this case, through the value we're looking at. So 0 through 18.49 is going to be our new value 1. Then we're going to look for the range of values between 18.50 and 24.99. So then we're going to click this range and type 18.50 through 24.99. And that value, oh no, sorry, let me do that again, 18.50 through 24.99. And our new value in our new variable will be 2, because it'll be a second category. And then the third option, we're looking for any BMI value of 25 or higher. So we're going to click this range value, that's the value we're going to type in this box, through the highest value in the data set. So if we click there and type in 25.00, we get the value 25.00 through the highest. So any BMI in our data set that's above 25.00 will be included in this third category. Make sure you click add for each of these and you have all 3 of them. Once those 3 are put in, we'll hit continue. And then we'll press OK. Then we get our output window which pops up. So here it's just telling you that recoded the original variable BMI, the lowest value through 18.41 is our new category 1, 18.50 through 24.99 is our new category 2, and 25.00 and higher is our category 3 in this new variable. So if we go to our data view, now we can see that on the very end here, we have this new variable, BMI R. What we want to do is go to variable view. I'm going to get rid of the decimal places because we don't need them. And then we're going to go into values and label these values. So if we look back here at our assignment, value for 1 is underweight, which is 18.49 or lower. Value for 2 is normal weight, and that is 18.50 to 24.99. Add. And then our third value would be overweight / obese, and that would be 25.00 or higher, sorry. Click add, and then we press OK. So now we can see here in this values that it has the values for those categories we just put in. And if we go back to data view, now you can see that it included those instead of the numbers because I have this switch turned on. It's switched up here, the A and the 1. So what I'm asking for here with the frequency table output is for you then to go into Analyze, Descriptive Statistics, Frequencies, bring over this new BMI variable, and click OK. This is the table I'm looking for to see that you had these original 2022 individuals in the sample, and this is the table that I want you to put into your document. So you can copy and paste it like that, or you can take a screenshot and insert that into your document. So that's what I was looking for in this in the frequency table output. So if you didn't include the right thing when you for the assignment, this is what I'm looking for in the future. The other thing it talks about is using the crosstabs procedure to check. So that's when we go into Analyze, Descriptives, Crosstabs, and we bring our original BMI over in the rows and the new variable in the columns. Now we're just going to press OK. So a few people included this table instead of the other frequency table. This is actually just checking to see if the values were put into the correct categories. So on the left side here, we have all of the original variables from lowest to highest in our data set. And there's a lot of them, so this is a big table. But how we can check this is we know that everything under 18.49 should be in this first categorized variable. So we want to look down to 18.49 and make sure that there's zeros in the other two rows and all of those individuals are in this first column. And they are. Then we're going to check normal weight. So any value between 18.50 and 24.99 should be in this middle column. So 18.50, so we don't have anyone with that exact value. But if we look here, there's this 1, and then all the way up here, we keep seeing those values until we get to 24.99, which doesn't exist, but here we go. This is where the cutoff is, and there's zeros in the other two columns for that, for those original values. And then the third column is anyone above 25 or above BMI. So then we look in this third column and hope that all of these values are in the third column and not in these first two columns. And we see that they are, and that's what we're looking for. Now, another way to check that you did this recode correctly is when you run this crosstabs to see if there's anything missing. If there's any missing values here, you did something incorrectly. For all of the assignments for the rest of this class, there will be no missing data for anything we do. So if you have something other than 0 in this missing section, something went wrong and you need to retry what you were doing. So now that we did that, let's recode the creatinine variable. So here, if we go back to our data, and we look at the creatinine, the original variable, it was measured continuously and there's a range of values here. So we're going to do the similar thing we did for the BMI variable. We're going to go to transform, recode into different variables, and then we're going to hit reset because we're starting a new variable. So then we'll come down to CREAT, the creatinine, the original variable, and pull it over. Our new variable, I'm going to call it creat_r because it's the recoded version, and then label it recoded creatinine levels into categories. This doesn't have to be exactly what I'm saying here. I'm just looking for you to have something so you know what the new variable means to you. So then next, after we click change, we're going to go into old and new values. So here we just have two different categories instead of three. So in our original data, a normal value would be between 0.500 and 1.200. So we'll start there with our original variable on the left. So those original values of 0.500 through 1.200. And in our new variable, that will be a value of 1, which we'll later label as normal. And then for abnormal, there's two ways you can do this. You can either do all other values and label that as 2, or you can do range value through highest. So the value would be 1.201 through highest and have that as your second. So either of those would have worked correctly. So that's what we'll do for that, and then press continue. Then we press OK, and we get just this one little pop-up here that says the recode happened. This is what we created the variable label as, and it was executed. So then we will go back into our data set, go to variable view, and here at the bottom we see we have this new variable. Again, I'm going to get rid of the decimal places because they annoy me, but that's up to you. Then our values here will be 1 equals normal level, so 0.500 to 1.200, and 2 will be abnormal, which is 1.201 or higher. And then we press OK, and then we see that shows up in our data file as those labels. And again, if you like this better, that's fine to look at, or you can turn this 1 to A off and it'll just show you the number values in the data view. So now we want to check and make sure our recode was done correctly. So we're going to go to Analyze, Descriptive Statistics, Crosstabs, and we're going to reset this again. And we'll bring over our original creatinine variable into the rows and our new variable into the columns. And then just press OK. And here, this isn't quite as long as the other one, so it's a little easier to read. So here we want to make sure that the normal values, so anything between 0.5 and 1.2, were in this normal category. So we're going to look down the values in the left column here. So 0.0500 all the way up to 1.200. That's what we wanted to have in that first column. So all of these should have numbers, and then the other side here should be 0. And then down here, once we get to 1.200, our second category takes over. So these are abnormal values now, anything from 1.201 and higher. So here we can see that these values all fall into that range, and all of these are zeros. And again, we see that we did this correctly because of that crosstabs, as well as we have no one missing here. Next, we're going to run the frequency table to put into our output. So we'll do Analyze, Descriptive Statistics, Frequencies. And then we're going to bring the BMI recoded variable back and bring over that new creatinine variable, the new recoded variable with the two categories. And then we'll press OK. So here we can see that we have 0 missing. Again, another way to check to see if you have anyone missing. If you have someone missing, you did something incorrectly in this class. And then we have our frequency and percent as for each of the values. So I'm going to copy this and paste it into my Word document. So those were the two frequency tables I was looking for. So if you need to include a frequency table output in the future, these are the tables I'm looking for, the ones that have the frequency and percent. All right, now we're moving on to the table part. So here we have a table, and I wanted you to make it into APA format. So that means we need to include a table title. So in this case, this is descriptive statistics for a sample from the DIG study. We want to include the total number in our sample, which we can see if we just look at this, or we can run a descriptive statistic on the ID variable. And what this tells us is that there's a total number of 2,022 individuals in our sample. So that was one of the things I was looking for, is you to have some sort of table title. The next part of APA format, let me make this a little bigger so you can see, is to get rid of some of these lines in this table. Now, it's up to you if you do this before you enter the data or afterwards, but I like to do it before so I don't forget to do it. So I'm going to highlight all of the columns here, and I'm going to get rid of all of the borders first because that makes it easier for me. So I'm going to click on the borders and get rid of all of them. So now if I unclick, so it still looks like I have borders here, but that's because I have, in my layout, I have it showing me the grid lines, so I'm going to turn that off. So now you can see that there's no lines. Okay, so we're going to highlight this header row. So that means the row that includes the title for what's in this column, as well as the titles for these other columns. And then we want to have the header, the row, have borders along the top, underneath the title, above this top part of the row, and we want to have it underneath that row. So underneath those titles. That's one place. And the only other place to have a line is at the very bottom of the table. So this is the last row. So we're going to highlight that row, go into our borders, and click bottom border. That is APA formatting for the table with the lines that I'm looking for. All right, so now we're moving into the descriptive statistics portion. So we wanted to find either the mean and standard deviation or the number and percent for each of these variables. Again, here we can put the number of the total sample, so 2022, because that's our number in our total sample size. Let's start with finding the age. So since we know that age is measured continuously, that's what we identified up here at the top, we want to find the mean and standard deviation. If you have a continuously measured variable, you're always going to be reporting the mean and standard deviation. If you have a nominal or ordinally measured variable, you're always going to report the number and percent. So for age, we're going to create that descriptive statistics table. So there's two ways to do this. The first is analyze descriptive statistics frequencies, and then we'll reset this. We'll bring over age. Then we'll go into statistics and click off mean and standard deviation. Click continue, then click OK. So what we're looking for in this table is not the frequency table. We're looking at this statistics box up here at the top. So here we have the mean age as well as the standard deviation of age in our total sample. So to bring that over, we're going to type in 63.40. The plus or minus symbol, the easiest way is to just copy and paste it here. And I'll unbold and italicize it. And then we will type in the standard deviation, 0.3. Now, if you wanted, you could include just one decimal place, so it would look like this. But make sure you're consistent. So if you include one decimal place for this continuous variable, for any other continuous variable in this table, you'll want to use only one decimal place. So let's look down at gender next. So gender is measured nominally. There's two categories. So if we report a mean and standard deviation for gender, it's going to mean nothing. So analyze, descriptive statistics, frequencies. Here we'll move back over age and look at gender, and we'll press OK. So if you've got this mean and standard deviation values that came up, what does that mean to you? It doesn't mean anything because this variable is not measured continuously. So these are meaningless. What we really want to know is the number or frequency and percent of individuals in each gender category. So the number and percent of males and the number and percent of females. So males are first for our total sample here. So we'll click in that correct area and we'll type in the number or frequency of males, 1543, and then the percent, which is 76.3. Then we'll go down to female and do the same thing, 479 and 23.7. So that's all you need to report. We'll leave this row here, right here, blank. Next, we're going to come down and do BMI. So originally, our BMI was measured continuously because it was continuous variables. But I asked you to report the newly recoded variables for BMI. So we want to report the number and percent that are in each of these BMI categories. To do that, analyze descriptive statistics, frequencies. Go to our new BMI variable, so our recoded variable. Bring that over and press OK. So here we can see it comes up at the end. This is the values we're looking for here. This mean of 2.61 and the standard deviation of 0.528, they don't mean anything in this case. So we just want to report the total number that are underweight. So in that case, the frequency is 41 and the percent is 2.0. Since I included a decimal place in gender, 1 decimal place for the percent, I'm going to still include that 1 decimal place here, even though it's 0. Next, we have normal weight, and that's 707 and 35.0%. And then overweight is our last category, 1274, 63.0%. So next we're going to look at serum creatinine levels, and that's also our recoded variable, and also the activity limitations, since that's also measured nominally or ordinally. So we're going to go to analyze descriptives, frequencies. We're going to reset this, and we're going to bring over our new creatinine variable, and we're also going to bring over that activity limitations variable. So we're going to have both of them, and what we're going to do is press OK, and what happens is it brings up the frequency tables for both of those at the same time. So this makes the process a little bit faster if you are able to do them all at once. So here we'll type in the normal frequency for the creatinine level was 1008 with 49.9% of the sample. Our abnormal count was 1014 with a percent of 50.1. And then now we can also look down here at the limitations of activity. We see that none was 146 individuals, or 7.2% of our sample. Present limitations were 342 individuals, 16.9%. Past was 321, or 15.9%, and having both past and present limitations were 1,213 individuals, or 60.0% of our population. So to get those values, again, you look at the frequency column and the percent column. This valid percent and cumulative percent, the valid percent refers to if you have missing data. We're not going to use that in this class since everything will not have missing data. then the cumulative percent should always add up to 100 in this class. So if it doesn't, something went wrong. All right, next we're looking at the total sample to get the heart rate average, the average number of symptoms, and the average number of hospitalizations, since those three variables were measured continuously. So I'm going to show you the other way to do it besides going to the frequencies tab. So instead we're going to go to Analyze, Descriptive Statistics, and then Descriptives. So it brings up a very similar prompt as the Frequencies tab. But now we're going to bring over the number of symptoms, heart rate, and the number of hospitalizations. And we want to make sure they're in the same order because that makes it just a little easier. And now that's all you have to click in this one, and we'll press OK. And what comes out now is just a descriptive table that has the total number that are in each of those categories, the minimum and maximum values, which we're not concerned about right now, and then we have the mean and standard deviation values. That's what we're looking for. So let's move this over just a little so I can still see it when I'm in my Word document. So heart rate, let's see, we have, oh, I don't have them in the same order. That's okay. So make sure you're looking at the right column, the correct column when you are in your table versus your SPSS output. So heart rate would be the second row. So we have a mean of 78.45. So since I used only one decimal in my first continuous variable, I'm only going to use one down here as well. So 78.5. Then we're going to include that plus or minus symbol, 12.6, because our standard deviation is 12.568. If you don't want to include this plus or minus symbol, what you can do is put in parentheses here. You just have to make sure you then change it up in this header row. So if you don't like that plus or minus symbol, you can do it like that. You just have to make sure you're putting in the mean and standard deviation where it belongs, and not the number and percent. Then the number of symptoms. So if we look at our table, there's a mean number of symptoms is 3.66. So 3.7 plus or minus, our standard deviation is 0.778, so 0.8. And then the number of hospitalizations, our average or mean is 1.96, which would be 2.0 in this case, plus or minus the standard deviation of 2.7. So that's how we get these values for our total sample. There's one more thing we need to do before we split the file by this myocardial infarction status. So we want to run a frequency on MI status, previous MI. So we'll bring that over and press OK. And here we get the number and percent of individuals who did not have a previous MI and the number and percent who did. We want to make sure to put that in this top row, in our header row. So the number that did have a previous MI was 1332, and that was 65.9% of our sample size. And the number that did not have an MI was 690, and that is 34.1% of our sample. So I want to make sure if you're breaking up the sample into two columns, so splitting by one characteristic of the sample, you include both the number and the percent of the sample. If you have the total sample, you do not need to include 100%, just the number of individuals. Now we'll split the file so that we get results split by the people who have had an MI and those who have not. So to do that, we're going to go to Data, Split File, and here we get a pop-up box. So how do we want to analyze the file? Do we want to analyze all the cases and not create groups? That would be what we want to use for the total sample, so we don't want to use that right now. We want to compare groups. So we want to compare groups based on myocardial infarction status. So we'll bring that over. Our file is not sorted already, so we want to make sure that we have the sort the file by grouping variables. And the groups are based on the variable MI status. Then we'll press OK. So what that does is it just pops up this little dialog here that says sort cases by the previous MI status, and then it splits the file by that. Now let's run some statistics. So let's do all of the continuous variables first. So we're going to go back to Analyze, Descriptive Statistics, Descriptives, and we'll bring age over here too. That way we have them all at the same time. So those are our 4 continuous variables. Since we have the file split, when we press OK, it's going to give us values for those who did not have a previous MI in the top, and in the bottom it will give us the people who have had an MI. So let's do age first. So for those who have had a previous MI, this bottom part, what is the average age? Let's look. If we come over here to the mean and standard deviation, we see that the average age for a previous MI is 63.5, plus or minus 11.058, so 11.1. Then for no MI, we're going to go to this top row and see the mean is 63.2, and the standard deviation is 10.99, so 11.0. Now if you rounded to 2 decimal places and you had 10.99 here, that would also be fine. If you're in a couple decimal places of rounding correctly, I'm usually okay, as long as you're consistent across your table. So if I had 2 decimal places here in my no MI group, I would have to have 2 decimal places for all of the other continuously measured variables as well. Now let's come down to the previous MI and heart rate to find their average. So if we look at previous MI, heart rate, now we're going to come over to the mean, 78.8, plus or minus our standard deviation, which is 12.4. Then we'll also do our no MI, so heart rate, mean, 77.8, plus or minus 12.9. Number of symptoms for the MI group, 3.65. Oops, that's 3.7, plus or minus the standard deviation, 0.8. Number of symptoms in the no MI group, 3.7, plus or minus 0.8. Now the number of hospitalizations for our people that did have an MI, 1.9, plus or minus our standard deviation of 2.4. And then the number of hospitalizations for those without an MI would be 2.0, plus or minus 3.1. So that's how we get the continuous values with the split file. Now the file is still split because we didn't turn it off, so now we can still go back and do our nominal or ordinally measured variables. So let's hit reset and bring over those other variables we're looking for. So we need gender, we need our newly recoded BMI, we need our newly recoded creatinine level. Oh no! It just quit SPSS. Hold on, everyone. All right, now we have our file still split by previous MI status, and we want to find these nominal or ordinally measured values, their number and percent. So analyze descriptive statistics, frequencies. Then we'll bring over gender, our newly recoded BMI and creatinine levels, as well as our activity limitations. Then we'll press OK. So here we have our output. It tells us that we have no one missing from our analyses. Excellent, that's what we want to see. And now we have our values, and they're broken up by MI status. So let's start here with previous MI. So they answered yes, and we're looking for the number and percent that were male. So said yes, male, number 1021, percent 76.7. Then we can just go down and do females since it's here. We had a total of 311 and 23.3% of people who had a previous MI were female. Now we'll do no MI. So the number and percent of males would be 522, and that's 75.7% of those who answered that they did not have a previous MI. And then for females, 168, which is 24.3% of our sample who did not have an MI. Now we're going to come down to our, oh, looks like this didn't work right. So let's go back and look. I must have done something. Hold on. All right, so we're going to our frequencies. We have the 4 variables we're looking for. Okay, so we already did gender, so let's go down here to myocardial infarction status and BMI category. So we're looking to see if they were in the yes, they had a previous MI, and the number and percent of underweight. So yes, underweight, 32, 2.4%. Then the normal weight, 475, and that is 35.7%. And then our overweight or obese would be 825, which is 61.9%. Now we'll do the no MI, so that's the top part. So 9, we're underweight, 1.3%, 232 or 33.6%, and then 449 or 65.1%. Again, since we have the percent symbol up here in the header row, we don't need to include it in this text part of the table because it just makes it look a little cluttered. So then serum creatinine levels. So we have, that's this table here. So again, broken down normal, abnormal, and had an MI. So that's this first part here. So normal was 674, and that's 50.6%. Abnormal would be 658, and that is 49.4%. Then we'll go to the no MI. The normal was 334, or 48.4%, and our abnormal was 356, or 51.6%. Activity limitations, so that's our last table down here, and that will be the end. So here for previous MI, we'll look at the bottom, no limitations. 100 individuals, or 7.5% of those who had an MI. Present limitations, 226, or 17.0%. those with a past limitation, 199 or 14.9%, and those who had both a past and present limitation, 807, which would be 60.6%. Go to the no MI, we have no myocardial infarction and no activity limitations for 46 individuals, 6.7%. Those with present limitations, 116 or 6.8%, 16.8%, sorry. Past limitations, 122, and that is 17.7%. And past and present limitations is 406, 58.8%. So here you can see that we have our total sample characteristics and then the characteristics broken down by myocardial infarction status. Something to note is if you were to add the number of individuals in the previous MI and the number of individuals in the no MI group across each category of nominal and ordinal variables, they should add up. So an easy example is this no activity limitations. Our total sample was 146 individuals. Okay, so if we split that and there's no one missing, we have 100 people in the MI status and 46 in the no MI status. If we were to add those two broken down into together, it would be 146 individuals. So we know that we did this split correctly. I think that is all I needed you to do for this one. Hopefully this was helpful, and if you have any questions, please let me know, and I will be happy to help you.